All right, let's stream this thing so everyone can see it online again afterwards. So software quality management is a big topic here, and you noticed already, probably based on the discussion today, that this particular paper here, or this particular course, is all about quality management, right? So it's about, thanks for joining us. Thanks for doing so. It's very timely as well. It's all about process, right? The entire course, you realize, right? Of course, you need to develop tools and software and so on, which many of you did as part of your bachelor work as well. One of the things that we want to harden the masters is, of course, that we want to make software or software development less a process of art, but rather more a process of science to some extent, or at least having a methodical approach towards it, right? So that's pretty much what this is about. For you guys, did you hear talk about software quality before in the bachelor somewhere?
Not sure. I'm not sure about that actually, but maybe in like a chapter in one of the courses.
Yeah.
Probably
Applikationsentwicklung or something. I don't know. Yeah. Okay. Just checking in. So. If it's pure repetition what I'm doing here, then interrupt me, right? So I'll ask you at any time if you have something to chip in, because I know you're all coming from very diverse backgrounds. So sometimes you may know a lot more about a different topic than someone else and so on. So you should equally be involved here as well. But as I mentioned before, so it's really about making you methodical practitioners in writing software, right? From a design perspective. But also from managing the process, right? These questions were always, okay, how do you estimate this, right? How do you guess this? And those kind of questions that really point towards, in the end, developing not only a tool with certain quality characteristics, but also having a process that meets certain quality criteria. Because if you all have roughly the same approach towards managing the process, the likeliness that you collectively as a team working together is much easier in a professional setting than if you all have your individual intuitions of how to, for example, estimate story points and things like that, right? So hence many of those courses point in the kind of same direction, right? So they're sometimes a bit lengthy and seemingly dry, but they give you a good repository of methods and techniques you can employ to actually deal with this. Before we talk about software quality, we talk about quality. What's quality actually?
Item or product being up to a set standard.
Yeah, good. Other points? There's no one right solution, so not yet. Wait for the exam. No. There was a temptation,
no.
Purely instinctive. Okay.
Well, I would say that it's code that follows the requirements without too many unforeseen bugs.
Okay, so that's the software developer speaking there. Yeah, that's good. So if you think about, just remove the software bit, right?
Yeah.
Just quality itself, right? A high quality experience, high quality hotel, high quality car. What does quality mean in that context?
When the expectations of the user for the product is met or exceeded.
Correct, right? So exactly, it's about expectations largely, right? We ignore this completely. But what's the thing about expectations? Do we all have the same expectations to a product? We're all over the place, right? So we have all different preferences that determine what our perception or expectations actually are, right? So for some of us, it means a product may be of very high quality, whereas other people with high expectation in that regard may say, oh, it's actually fairly average, right? So, by the way, if you use the term average, usually means really bad quality, right? I don't know. So, what's your connotation with this? So, but no one will ever advertise something with, please buy my low quality product, right? So, that's not going to really happen, right? People always claim, or at least when they want to do something that something exceeds someone else's expectation. But do all products exceed our expectations? No, they don't, right? So we also need to be aware that sometimes we actually deal with low quality. But this term is highly overused. But the thing is, it's highly subjective, right? The point is, expectation is a highly subjective term. When we're talking about software, you don't want to have it be, it shouldn't be like an art, but more like a science, if you like, closer to it anyway. We're doing the Master of Applied Computer Science, voila. What do we need to do to actually establish quality, a set of standards? Who was it you were, right? How do we establish that? how do we get from subjective to objective? In short.
You can measure it.
Exactly, right? So we're the master of metrics, right? It's all about quantifying everything as far as we can. That's what those Dipty's point was about, right? If you make an estimate, you know, how do you know what's your indicator? What's the heuristic you apply? Your experience, you know, perhaps you in your group discussions. So we know that collective evidence is usually superior to individual intelligence, meaning your estimate will be more accurate if you ask your group members than rather estimating it on your own, unless you're an expert. Those kind of aspects. So we need to find a way of converting it somehow into something objective. And that's pretty much what this talk is about here. It's really about what quality is, what it is specifically, of course, in the context of software, right? So you can apply it to anything. You can apply it to economics, to marketing, whatever else. But of course, we have a sense of quality in software as well. So it's about really coming down to metrics. So if we talk about product quality, what are the qualities we are generally associating with products?
Durability.
Oh yeah, durability is one. Yep, cool. So it would be closer to what you mentioned, which is requirements, for example, right? You have certain properties that you expect. Durability needs to last 10 years, right? Or you want to guarantee as a manufacturer, you can give a warranty of 5 years. Well, that stupid thing better last more than 5 years, right? Else you're in trouble. So that's a quite sensible move there as well, right? So it can also be, of course, fitness for use. That's a more, does it actually do the job? It can be free from errors as a requirement, and customer satisfaction. So those are examples for product quality criteria, but you see it's not uniform. It's not just, okay, we have a fixed set of criteria we can apply. They largely depend on the market you're in, the product you develop. And some of them are actually a bit more, can be specified in advance. For example, those two ones, rather, I would say that in conformance to requirements that are set out in advance can be measured during development, right? Whereas customer satisfaction is fairly hard to measure during development, right? So yes, you can do a bit of alpha testing, beta testing, and so on, and early releases, but fundamentally it's kind of up to the customers in the Google App Store to vote your app, because that's where the real review is actually going to happen, right? So even if we try to quantify it, we can't necessarily control everything in advance, but we need to do it over time. All right, cool. What's this talk about? So a lot of different stuff. This is like a massive a repertoire of different points that are supposed to be covered as part of this course. And we'll see if we dive through all of them or if we cut short on some of them. In any case, I give you the full slide set so you can use it as a reference. The point there being, there are some aspects in there, may not be super obvious at this stage, but there are some aspects that are very valuable for you later on when you when you apply to your particular project, right? So we'll talk about this because you can borrow some of the catalog of criteria and metrics that I'm talking about in your own work. All right, we're talking a bit about software quality, non-functional and functional requirements. You guys know what that is? No? Do we need to do a hand count? Yes, one person knows it. Really?
Functional is what the product should do, or like what way it should solve our problem or like satisfy our needs.
Okay.
Non-functional is probably like design should be like excellent, or like there must be like picture of something.
Right. Okay. Okay. Other views?
Well, functional is covering functionality, kind of, right? If I remember correctly.
Mm-hmm.
And non-functional could be business-wise requirements, but it could also be like some measurable thing like the system needs to respond within 2 milliseconds or something.
Ah, there you go. Right. Performance requirements, for example, right? So they don't describe function per se, but rather how the function is performed, right? Second order, right? So one hard requirements, well, that's an odd term because sometimes it's a lot harder to satisfy the non-functional requirements than the functional requirements, right? So that's right. So you guys heard about those things before in some lecture, right? Who has not heard about this? Because I have more depth. Cool? Okay. Cool. Software requirements. Then we have quality factors. So we go into some of those aspects afterwards again. We have quality factors and criteria. Then we're diving down to actual metrics or measures. So how do we measure software quality? more explicitly. Welcome. That's brilliant. Okay, question for you. What are software quality factors? Since you're so timely.
Software.
Or did you hear about this in any other course before? Because I was just making the rounds and just checking who has heard about anything related to software quality before in university settings. I know you have a lot of professional experience. Let's forget that. But
no, I think when I studied at Dundee, we covered in third year code complete and sort of professional coding standards.
Right. Okay.
So we're talking about readability, lack of keeping complexity low, cohesion in your classes.
Oh, nice.
Single responsibility, testability as well. So, for instance, like if you can run it through unit tests or integration tests.
Yeah.
Is this sort of
yeah. So that's on the software, really on the development side, right? So really hard metrics. So we're talking about exactly where you are already, in a sense that come up with metrics for something, right? So if you want to keep cohesion low, you need to look at the relationship, your conations. I'm not sure if that concept came up. It's basically the linkages between different characteristics of dependencies between object and object orientation. So there are all different kind of metrics that you can apply for those kind of to measure quality. Because the challenge is, what is quality in the first place? You had
I was wondering, what is the term for the graphs that you can get where you actually can visualize all of the connections a class has? So you can see if you have a particular class that's basically creating a big ball of mud or spaghetti code, because you can sometimes visual the connections, and you can get code analytics tools to provide that.
Yeah. I don't know what the academic term for those would be. No, but I don't know. Often they represent. I mean, the way I have seen them represented is like a force-directed graphs, where they basically model classes together by location, for example, and associate stronger force weights. So they actually, form clusters, and then sparser weights, of course, for more, remote relationships. So basically, you have those clustering setups. That's usually the conception I see, and then it can move around in them, right? You can navigate them to some extent, but I don't know what the formal term for those would be. No, but I know what you mean. That's a good point. In fact, it's kind of a bit similar to what Simon talked about, like the last session before that, forgot. Anyway, Simon talked about this, but with respect to versioning commits, right? So how teams work on different aspects of a software over time. Cool. Right, we talk about challenges, we talk about management activities, some quality standards, which you dig into and bring them back to Agile. And that's the worst thing. It's not the only presentation I'm supposed to give to you, because there's one on documentation. So I'll keep it as brief as possible. That's the whole game. So, okay, coming back to software quality. What is software quality? Well, 1979, so it's not too recent. They said it's basically meeting a set of specified requirements, precisely your definition. So you seem to be the software developer. You're spot on already. All right, now we're getting messy here, right? So you have this term expectations in there. Oh, God. Okay, so it becomes much more subjective. It's no longer about hard engineering, right, and getting the requirements right, but actually you're responding to your users' needs. So you see a shift over time. So there's quite a bit of specifications out there, and then it becomes much more complex, but also considering implicit characteristics that are expected of all professionally developed software. And that's where the messiness comes in, because it's qualities that you carry around with you. They may not be written in documents, but it's things like best practices, right? Coding standards. You talked about this, right? So how do you operationalize keeping cohesion low, or maintain testability? How to do documentation? How often to do documentation? On what level to do documentation? And things like this. So they all play into this more advanced representation of quality, because it also reflects focus on different stakeholders. It's not longer just the users, but also future developers. What people realize is that software may actually be used for long term, right? The lifetime of software generally exceeds the lifetime of hardware by far, right? So we usually, in a professional commercial setting, we assume that hardware persists for 3 years roughly, then it needs to be changed anyway, at least from an accounting point of view. But usually software survives that considerably, and data even longer, of course, but that's a different problem. So it's kind of a bit of a challenge. So we have functional and non-functional requirement. is usually laid out as part of the specification document that you negotiate with your customer, or that's laid out by customers. Sometimes very good, sometimes not so good, right? My group knows that. It's a bit flaky sometimes, right? So there's more, may be more opportunity for refinement, for discussion there. So they're fairly objective in any case, because they're usually quite measurable, right? So it's in a sense, okay, did you fulfill this requirement or not? I mean, I think about it as a Boolean function, basically, right? So, I mean, you check the requirement, is it met or not? If you can't make that assessment with a true or false return, then most likely your requirement is not a good requirement, or it's actually not a requirement in the first place. So, in any case, it's not really measurable there. So, to make things hard, so this is about boiling down things to actually something that is somewhat measurable. There is a set of quality factors, and that's where, on the one hand, the usual scary slide sets come in, where you have a lot of different stuff that's listed, in this case 11 points. But on the other hand, they give you a kind of a blueprint of all the aspects you could think about when developing a product, right? So it's quite cool because you can carry it along and think, okay, is that relevant for my product? Yay, nay, yay, nay, yay, nay. So it's kind of a checklist approach that you can apply. So even though it looks equal, a bit evil sometimes or overwhelming, it's actually more a helper than anything else. And exactly, in some cases you have some of these abilities are important, like scalability, maintainability, or reliability. In some other cases not, right? So for example, if you're emphasizing portability, for example, specifically, that may influence the choice of your programming languages in the first place, whereas other aspects may come as an afterthought. For example, scalability is sometimes not really considered. Cool. Non-functional requirements. Let's try that again. So we had some there, some bit feedback. What were non-functional requirements? We had some good injections. I want a richer picture. More. No?
You said performance earlier, but also maybe like uptime and stuff like that.
Ah, that's an argument. Yeah.
Like availability.
That's right. That's right.
Stability.
That's right. So it's generally that they are. You're right. You're spot on. It's basically that they are usually global constraints, most likely, right? They affect the system in its entirety. So if you have a system that has a set of functionality that you need to fulfill, it's relatively straightforward to go through your user interface, click around until you figure out, oh yeah, it does that. What functional requirements often don't actually capture is that they have a more like a local scope, right? So they are like modules of a given software product, or not the system as a whole necessarily. Getting to anything. Whereas the non-functional requirements are usually much more cross-cutting, right? Measuring performance, you probably wouldn't want to do that on a particular module, but you need to do it over system, over the entire system. Please.
So for design and usability, would that be a non-functional requirement then? As it sort of covers the whole application?
Yeah, I mean, I would put it in this category. First of all, there's an ility at the end. That's usually an indicator, because, second of all, because it's highly subjective, right? So, but another heuristic that I tend to apply is whether the metric is discrete or continuous. So in functional requirements, it's generally a discrete metric. It's again Boolean, in fact, right? So, or put it this way. Done, partially done, not done, right? So, whereas in this case, it's more like a continuum, right? Performance could be arbitrarily improved, right? To a response, to a latency of 0 milliseconds, which is of course not achievable, but you want to get as high as possible. In your case, it's about usability, get as high as possible, right? So, a system may, in 2 years, still satisfy the same requirements it was set out to be developed with, but the usability may change over time because the users may change, right? So, so usability clearly falls into the non-functional perspective of, at least in the software case. Yes, in the software case, certainly. So, a good indicator, if there's an ility at the end, is most likely a non-functional requirement. I'm not sure if it's really helpful. But the thing is here to bear in mind that it's really about continuous metrics often and cross-cutting concerns. So it's not just one unit or one module of the system is affected, but the system in its entirety, right? So it's super important here that we look at it, especially from an integration perspective, that you early integrate your systems when you develop them in order to make this stuff actually measurable. Because it helps you very little if you measure individual components, because it doesn't necessarily mean that the metric that you have at the end is the sum of the components. Is actually probably something else that you don't really anticipate in advance. But you see examples here as like development cost. Okay, those are minimization, maximization concerns. You will not get a development cost of 0, but you can minimize it, right? So it's an optimization problem here. Operational cost should be minimized, robustness should be high, portability, maintainability, and all that stuff looks painful and it's oftentimes super hard to specify in the first place. Because, the obvious challenges is that they may be contradictory, so they sit in conflict to some extent, right? Sometimes reducing operational cost may be in conflict with developmental cost. So if you put more effort into a system to keep the operational cost low, it will cost more on the production side most likely, right? Because you expend more. Yeah. It's super hard to enforce during development because you can only see the metrics once you bring the entire system together, right? If most of you guys are working, or many projects that I heard so far were you guys distributing between front end and back end development, but you will only get a feel of the system overall once you bring it together, right? So if you delay that too far, you will actually not be able to actually address those guys in the first place. And yes, make them measurable. And here's the thing, there's no standard way necessarily of making things measurable. That's something that needs to be decided as well with the customer, right? So a product owner needs to say, okay, those are the metrics I apply to usability, right? They may be very different for a different case. Whereas for functional requirements, does it do the following or not? That's kind of a universal metric that is relatively easily accessible as well. Right, questions, comments? Did you hear it before from someone else? No? Okay. Tell me if I'm repeating someone that someone else has talked to you about, then let me know. Because it's really a cross-cutting concern in itself, software quality. And voila! There we are. The McCall software quality model. It's basically a system of 11 different qualities that you need to learn by heart, otherwise you won't pass the course. No, I'm just lying. So I think it would, think about it more like, I can't remember that stuff. I'm thinking more like a catalog of different things that you can check. Is that relevant to my system, yay or nay, right? So and then can you assign metrics to it? For example, correctness. Well, is the system, does it satisfy the specification and satisfies user mission objective? Of course. Reliability, getting flaky there, may be relevant for some cases, not so much for others. So if you are, for example, developing for an industrial customer, you're most likely ending up with a yes there. You need to ensure high levels of reliability. They are then very willing on turn, often to sacrifice usability. If the system's reliability, that's much more important from industrial perspective, often, than usability. Integrity, big stuff, of course. Here it's about security in the widest sense, or at least to control access to the system within regular in a regular operational setting. So not in all cases can you ensure integrity, but the system is planned with this in mind, right? So testability, we heard this from Richard, for example. And here's a nice one, reusability, for example. This is not targeted as customers per se, it's actually more targeted as developers, right? Can you reuse components of the system for something else, right? You guys will know that quite a bit. And of course, interoperability. This is a tough one because this metric has a temporal component. Do you mean interoperability with the past system, with the present other system, or do you mean interoperability in the future, right? So those are all different concerns, and measuring those is pretty hard in a way. But in all cases, I think it's worthwhile to bear in mind there is something like that, right? And to know where you find it. That means in the slide set. No, wrong. Actually in the actual original model, right? But in worst case in the slide set. You can check it and see if that's relevant for you. I would encourage you for this paper here already to look up which of those properties are relevant for you, right? Perhaps the product owner didn't explicitly voice it, right? But they have tacit assumptions that you think about those things, right? They just expect that you think about usability. They just expect that your uptime is 100% of the system, right? They wouldn't know. Sometimes you need to, get it out of them, actually explicate it, right? Richard knows that all the best, right? From his professional work, we discussed quite a bit about this, so that many people have no clue what the heck they actually want, but it's most likely some of that, right? So bear it in mind. And now you see all the ilities, right? So they're quite important, quite prominent there in distribution. Okay, no one can learn this stuff by heart. Perhaps you can, I can't. So the idea was to categorize them, because you can look at them from different perspectives. if you look at correctness of a system, reliability, efficiency, and things like this, they mostly relate to operation of a product when the system is running. And then we have the other ones that are actually more involved with the development of the product, it's lifetime explicitly. So the ability to, for example, keep a system testable. Because why do you need to keep a system testable? Well, most likely if you introduce changes, right? So because if you have tested a system, it's deployed, you're probably not proactively testing it unless you're introducing changes, right? On some grounds basis. And maintainability, flexibility, so it's all about changes. And this one is about transition. So when you think about a successor of a product, for example, right? So classically here, which you would think if you work in a company and you're running an ERP system, which usually combines, do you guys know what ERP systems are? Some of you do, please. Forcefully, yes, one person, ERP, Enterprise Resource Planning Systems. Yes, cool. All right, so those systems basically are quite popular in many industrial settings, and I'll bring them up because you will most likely come across one in the future. They combine things like accounting, logistics, material management, inventory, production lines, and so on into one giant coherent system. And then, for example, there's the business process from a customer ordering something to creating the actual order, to creating a delivery node, which is sent to logistics, so they send out the material, to the factura, meaning the invoice, which is sent by accounting and so on. This is modeled by a relatively complex processes that are all associated and all integrated there. And half of the time that you think, when using those systems, you think about this. How do I get the data in from my old system? In fact, how do I get the data in of my old systems, often multiple individual systems integrated then, and how to get it out again in the end, right? So that's something, if you were responsible, you want to watch that one. Because the last thing is to have a vendor login on any of those systems, right? So it's very important there. Oftentimes more important than this one. Do you have a comment?
Yeah, sorry.
Right. So that's sometimes quite worthwhile thinking about. So thinking about those categories. Runtime, change, transition to something else, or from something else. Migration is a key point there, quite relevant. Is it? No? You can interrupt me anytime, just lift your hand, and then if you want clarification, have questions, or have examples yourselves, because I know that some of you have worked, and you either have active or had active professional lives, so feel free to share your experiences if they're fit. I think it's oftentimes a lot easier to learn by narratives than by learning by slides. So, all right. So we have the 11 quality factors which we now learn by heart. That's good. But there's this other thing. They are still very high level, right? So we still didn't have any metrics associated with this. Usability, maintainability, interoperability. Well, we need to have some sort of design criteria. And design here not in the in the usability design perspective, but rather from the software design perspective, architectural design perspective, where you can think about aspects such as completeness, consistency, traceability, visibility of certain components, and so on. So it's much more lower level there. So we have quality factors and design criteria which relate to each other, generally in a one-to-many relationships. So one quality factor may rely on multiple, or maybe associated with multiple design criteria. The examples brought about here is verifiability benefits from modularity, self-descriptiveness, and simplicity of a given components that are mapped. So, why do we break this down in this way? Well, it's again to make it accessible somewhat from a customer perspective. Here's the breaking point where you guys are more comfortable thinking about from a technical perspective, whereas the customer is perhaps able to communicate the high-level quality factors that they are interested in. So there's an intricate relationship between those ones. Cool. And here's an example. So we have the categories here. Well, that's one high-resolution slide. Brilliant. In case you can read it. Well, here's the product category, sorry, the quality category. Here's the actual factor that we're dealing with. And this is how it actually links to certain quality criteria. I'll read some of them to you. Again, nothing to learn by heart, but traceability, consistency. So traceability would be to be able to trace state through a system, right? So completeness of the system, that's straightforward. Consistency of the system. Consistency, what does that refer to?
that is, several users have the same interface, for instance, or same features.
That is a nice one. Yeah, yeah, cool. That's one sense of consistency. That's right. What else?
Like it works in the same way each time when you use it.
Yeah. What's the other word for that one? For that kind of consistency?
Workflow consistency.
Yeah, no, you have that's a computational concept. That's exactly what you're describing. Start with D.
Dependability.
Not quite. Determinism.
Okay.
Right. Same input, same output. Right. So that's similar to that one. Yeah. Cool. Well, one of the thing is state consistency problem, and this relates to what both of you said. In that, of course, every time you put in the same, you want to see the same stuff, and you mentioned that everyone sees the same thing, and that's actually what it is. Not necessarily from a perception perspective only, but also that the state of the entire system can be, determined at some stage, right? So if we have search engines, they operate probabilistically, right? So if you look at if you enter some, you're looking for a search term, you get an approximate number of results, right? So it's not necessarily accurate anymore. In different settings, it's very important to know exactly how much money on your account is. Not just roughly, with a margin of error of 10,000 krona, but actually you want to have it exactly, right? So consistency quality criteria may be quite important there, but they also come in different forms of fashion. So even there, it's still a bit funky. We're not quite clear about this sometimes. What's accuracy, right? So again, boils down to a very technical perspective. In your case, for example, do I use floats with doubles, for example, right? So in implementation, error tolerance. Okay, what's an error? And so on. What else? What could be interesting? Access control, training. So it's okay. That's a interesting one. How much training is required? System independence. Yeah, I think we're about there. So all those design criteria operate on a much lower level than what the quality factors would suggest. They're kind of combined, and sometimes they become really overlapping, especially when it comes to things like maintainability. Yeah, well, what does that mean? It's basically combining, in this case, simplicity, descriptiveness, modularity, but it usually combines many of the quality criteria, so it becomes quite messy there. And of course, then the quality criteria need to be operationalized in terms of metrics. So that's where the actual interesting thing comes into play. Well, now, if we measure usability, right? So, for example, we want to have a high level of usability as a quality, and we want to operationalize it. Well, first of all, how can we realize the usability that we want to have in our system? How much does training cost? And communicativeness. That's a good one. I'm not sure if there's a sensible example for this. But I don't know. In any case, how much it costs firstly to implement, but also how to train it. But sometimes also more about the intuitions that people have when they use the system anyway. So
that's like user experience design.
Is it?
I think.
Yes, probably would be. Communicativeness? Yeah?
Sounds like
Good. Everyone agrees? Okay, cool. I don't know. So yeah. So a lot of those different criteria. Well, again, don't know it by heart. It's just the thinking, right? So we have categories of quality. We have quality factors, quality criteria, and then some metrics down there. So if you're thinking about how to get from a very high level perspective of quality, subjective, to an objective perspective with a metric quantified, that's roughly a process you could imagine, right? So just to bear in mind. There. So the idea is that it allows for much more objective perspective and a relationship between the techniques and the processes they're using. It's one of the key things. So metrics. What metrics do you know more generally? I bet you use software metrics before somehow. Yeah. What are metrics in the context of?
Like for example, the performance thing.
Yeah.
Metrics and
Cool.
milliseconds in response.
Yep.
Or you could have how much memory usage.
Yeah. Cool. What other common metrics can you find? So you had response time, you had resource consumption.
We could go back to the number of links and dependencies.
Yeah, perhaps, yeah. Probably, count of dependencies. Yeah, this could be good. Yep. So modularity metrics again, rather, right? So in how far your modules are isolated. Yeah. What are other very classical metrics that are a bit ugly, but probably is the first metric that anyone shouts in the room? No?
how many lines of code?
Oh, brilliant! Exactly, that's the classic, right? So we know that's a bit ill-fated because that's I think it doesn't necessarily say much about the code quality, right? So because you can write really naive code, which is really long and or short, and conversely, you can have very complex code, which can also be long or short, depending on the approach you take. And also, it exists, of course, works with trade-offs with other performance metrics. For example, we have reusability as a metric that badly interacts with line of code. So usually, if you make something more reusable, it often means that it consumes more line of code in order to maintain this flexibility. Yeah. What else? Yeah.
Would it also include like a defect counting or working out like metrics how
nice.
often the class changes due to commits?
Oh, interesting. Right.
Because if you're
That could
constantly
be.
going back to a class
Yeah.
to fix it, or you have to keep on updating an interface because everything around it keeps on changing,
Yeah.
then that's
Yeah, it's a good indicator for. That's right. Yeah, there's some smell there. Yes. Good point. Yes. So some change metric that you could perhaps operationalize via versioning, right? So you can easily assess this. That's a nice one. Sounds like an interesting master's project. There. Other things related to production. When we think about that's something you guys need to do right now. When you are, what is the metric you are employing when you plan for your next sprint? Or put it more refinedly, which metric should you be employing if you're planning for your next sprint?
Hours used.
So again,
Hours used.
exactly right. So how many hours are used? Right. So it's very important, both in terms of to assess what's the actual time used as well, but also how efficient and how efficient your team actually is. Right. So exactly. So it can also be metrics like that that are quite a relevant one. So it's all about quantifying things, right? Some of them are very generic, like line of code, all that jazz. Psychometric complexity, you guys know that one as well? Yeah, probably. And some of them may be much more standardized, that they're used in software development more generally. Some of them are really more up to the product, the client in this particular context, or product owner, if you like. If they have certain metrics by which they want to measure the satisfaction of requirements. Cool. Right. One of the aspects of product metrics is, of course, that you need to do learning as well. So it's also the idea that you do analytics on your metrics. You want to see how your efficiency increases or decreases over time. Generally, you want to expect that you get done more per work hour, if you like, over time. Once your team gets on track, once you have a somewhat level skill set with respect to the specializations, if you like. So you want to see more efficiency. So you need to anticipate this. And generally would want to see increase in efficiency. That's something to really keep an eye on as part of your planning. And tools like Jira are quite helpful in that, because you'll see actually how your burn down chart looks like once you get actually going, and it really breaks down quite a bit faster. But it also means that you need to adapt your metrics, else you'll be underscoping all the time. So you basically assign yourself too little tasks, and you realize that halfway through the sprint. But I don't think that will be an issue here right now, because to be honest, this project is rather short-lasting. You have 3 months to develop something that doesn't, right? No? Yes, perhaps? Roughly, right? So that doesn't give much time forever anyway. Piggybacking on your points here, so some of the metrics are static, some of them dynamic, right? So if you think about the work hours one, dynamic one. If you think about the changing classes over time, also more like a dynamic one, if you like. I don't know. That's an interesting one. Could fall in both brackets, though, right? Because it's basically static code analysis, but you need to run it to develop it for some time in order to be able to assess it to some extent. But generally, it's associated the dynamicness with the program and execution, right? So performance is something that falls into this category. Reliability, uptime, those metrics as well. And the static metrics they are generally can be done basically on the repository, like assessing complexity, maintainability to some extent. Yeah, of course, they're all interlinked, so it's not a hard and fast kind of approach. So, but examples here, looking, for example, at maintainability, reliability, and some other characteristics, those could be example metrics. Number of okay, anyway, I read it to you, you need to believe me that it's actually written there. Number of procedure parameters, or psychometric complexity, program size and code lines, a bit medieval. Number of error messages, also a nice one. length of the user manual is also an interesting one. Yeah, don't know. It really depends on what kind of software you're developing, especially when it comes to documentation. But we come to back to that later in a bit. Yeah, so then the rest is basically about breaking down from criteria to metrics, right? So how do you operationalize this, right? So, okay, we have the issue of reliability, for example. Well, that's mean time to failure, for example, as a metric. How do you operationalize it? Well, you know, you basically count the crashes per hour, per week, per year, or whatever else, right? So something you need to agree on. Relatively straightforward. Sometimes, again, you can have multiple metrics and weigh them, right? So you're not only looking at the running crashes per hour, but perhaps you may actually relate this to the age of, for example, hardware they're actually using, right? Because sometimes it may not necessarily be caused by reliability issue, may not be caused by software, but by something else. You want to exclude that factor or control for it. Then you can introduce this into your metric as well if you needed to. Yep. Of course, yeah. Most common challenge is, of course, to deal with performance requirements. That could be operations per second, right? IOPS per second. That's how you measure scheduling algorithms in particular, right? So you focus on how many operations they can actually perform per round. The reliability may also be, it can be multiple aspects that you measure, for example, availability of components or rather the uptime. How do you measure uptime? Anyone? It's also a tough one or easy one. Is it hard or easy to measure uptime of systems?
But you measure it on like percentage, so like in a week, for example.
Yeah.
Like it was down 2 hours this week.
Yeah.
That's like 98%.
Yeah. Right. Yeah. Exactly. So you have certain how much time you can actually afford to be offline. Is it hard or easy to measure?
I don't know. Probably. I don't think it's pretty easy to measure how many hours it's down in a month or a week.
Oh, if anything, what's hard about it? If there was anything that's hard.
You won't really know until after something will happen.
That's correct, right? So you're only that's annoying. That's not necessarily hard. That's just the brute reality, right? It's hard to anticipate downtime. That's good. That said, you're of course not wrong, because if you have long-term metrics, you could aim to do predictions about your system, right? When is the point in time that my system more likely fails, right? So classical example, Christmas season, right? Just before there's a peak of customer requests, for example, and suddenly you probably can anticipate their system will fail if it has done so in previous years, right? One of the things is that network's reliability is not something you can assume either, right? So if you're measuring uptime of a system, it's actually not just one metric to get a ping back or something like this. You actually need to establish that it's not the network that is down as opposed to the actual system that's down, right? So sometimes that's tricky from a metric point of view. Usually you take multiple metrics and take the average then, right? So if you say you have a binary metric, you are available, non-available, available. So 2 out of 3, it's probably available, right? So the point is, even though it seems hard and fast, I can say I can establish it's running or not. Even that becomes probabilistic to some extent. Yeah. So it's quite interesting when it comes to this. So, point is why I'm pointing this out. Sometimes in SLA they make weird specifications, 99% uptimes, but you need to actually also figure out how they measure this, right? So it's always good to look one level deeper and actually inquire before you sign a contract. Hey, how do you measure uptime, right? Which standard do you use? So, different ways of doing this as well. Similarly, you need to confirm downtime. So you have a system that doesn't respond, you say, let's wait for 5 minutes and we confirm again. And only then, from then onwards, we confirm the downtime and consider downtime. This would be, of course, advantageous for your seller, not for you. Cool. Questions in between? Like? No? Good. So generally, as mentioned before, quality is a matter of balance. You can't optimize for everything. Specifically, conflict is developer and user. You can probably imagine that, right? So users want actually, have a bit of an overfitting with respect to the individual concerns, whereas developers want to have a very generic perspective, want to reuse a lot of components, have uniform widgets and whatever else, right? So, but they may not always fit user requirements perfectly as well. some quality requirements are, of course, again, hard to specify in unambiguous ways. For example, if you have quality requirements that refer to how code is commented, it may just strongly depend on what programming languages your developers favor, right? So if you come from a C++, that's the tradition, and you need to maintain Java code, or whether you come from a Java perspective and to maintain C++ code, it can actually vastly different outcomes in terms of which bracketing preferences people have, which commenting preference people have. If anyone has seen that before, you know what I mean. If not, then you'll see it in your future. So it's really like which programming language that you grow up with, you will use that. A lot of informal aspects of it, best practices, will spill over into other projects where they probably shouldn't belong. So again, here it's really hard to say what's high quality, right? In this case, high quality is uniformity, right? So you want to ensure that everything is specified the same way. Another interesting one is software specifications are incomplete and often inconsistent. How can that happen? How can they be inconsistent?
User doesn't know what they want, or they're unsure about the operating environment initially. So how much traffic you're going to get, for instance.
Okay.
What router do you have?
Right. Okay, yeah, that's the incompleteness, yeah. So you simply don't know. And the inconsistency, how does that come about?
I was thinking about what you said a few slides ago about measuring downtime. For instance, most routers have like a buffer for packets. So if you go over a limit, then you drop a lot of packets, and then the software will just become rapidly unperformant. So if you're just testing with a small subset of users, you'll go, oh, I've got a really good reliability, it never crashes, and then you'll just add some more users, and then suddenly your metrics just
fall over. Okay, yeah.
So you might get inconsistency in a different environment.
Right. But I'm thinking, that's a sensible approach. What I'm thinking about is more like the specification. How can change of standards and specification vary over time? And I think that's the comment there. But your point is absolutely valid. Scalability as a particular metric aspect.
So I'm thinking that the customer will have or will not be aware of certain items, for instance, security.
Yeah.
In regards to new products, if they want somebody else involved in new products.
Yeah. So
that's they might have a complete other set of requirements than what the developers want.
Yeah.
And over time they realize and they adjust for it.
Yeah. Yeah. So exactly, that's where your sensitivity as a developer needs to come in again and say, hey guys, are you sure you don't have any of those as well, right? So security is a classic. Of course, no one cares about security until it's too late. But we get a bit more sensitive right now, right? So in fact, you're in the right place here because you can study, of course, cybersecurity in EEC. But yes, something that's usually compromised. What I want to get at is different developers, right? Over time, if you maintain something over longer time frames, then suddenly specification, standard, and so on seemingly change slightly over time. And a good example for this, at least from as far as my practice goes, is the Android API, which is was initially quite consistent with respect to different usage of so-called managers for location, clocks, and whatever, all the system features that you actually have. But over time it has shifted and became quite diffuse. So you have multiple APIs that are overlapping in functionality, are probably in conflicting. Oh no, if you use that API, don't use that one. And aspects like this, which you wouldn't expect in a coherent operating system along with this API. And it's simply down to the fact that there's a lot of decentralization that people or groups of people can come up with their own new APIs, try them out, and if they're successful, they're embedded in the project without ever critically reviewing the big picture, the entire API. So you'll find that especially the guys that are working with Android, those ones there, right, isn't it?
Yeah.
You guys?
We are using Flutter.
Using Flutter. Okay. But at some stage you probably need to bypass Flutter a bit and perhaps use Android as well. We'll see. So you'll probably find some inconsistencies there. As a classic example, open source projects have it a lot because so many different people actually involved, and they don't necessarily have a single global maintainer, like Linus Torvalds, who would look at everything, but actually even the quality assurance is quite distributed, right? So this can lead, especially for growing projects, into a very divergent set of standards and specifications. So it's quite an interesting problem. Of course, the idea of quality is a bit of a chicken egg problem. When do you start implementing quality? When it's too late or when it's too early? So it's something you eventually need to attack in your development process and actually introduce in your system. Otherwise, it's not going to happen, right? So you can't just expect it to happen on its own. And sometimes you need to abruptly decide, okay, this is the new standard, and now we change everything in our software towards that standard, for example, in terms of annotations. But that's not happening overnight, of course. The other thing that is relevant in the area of quality management is, or the other aspect that's relevant is I implicitly alluded to, is the size of the company, of course. If you work in small teams, quality management is relatively straightforward, right? So, for example, here. So, if one of you develops and actually commits, well, two of you need to review, and it means the entire team knows the entire code base, right? So in larger companies, yeah, that's not going to happen, right? So if you're lucky, you get perhaps 2 reviews again, but again, that's just a minority or a minuscule subset of the entire developer base. If you have 150 people or something, and maintaining quality there is really, really hard just by relying on the individuals itself. So here, the idea is that it's more important to establish quality standards as well in documents. I know it's boring, that stuff, but still, you need to let everyone know what's the spec by which we're working, right? How do you comment in? How do you commit? What are you looking for? What's the notation we're using? Which code formatting do you expect? And what is our metric for security? And so on, right? It needs to be very, very clear. Otherwise, you run into a bit of an issues. And in this light, the quality assurance mechanisms operate on different levels, right? So quality assurance is basically setting out, before you do anything, you set out the rules of the game. You kind of have a bit of a quality culture that you want to introduce into your company. That's how you guys need to think. It's the onboarding process. I'm not sure if you know that. Well, if you have worked in a software house, it's often like this, that they give you a bit of a briefing on what the standards are basically are in the onboarding process. And this is basically that you learn about the organizational culture with respect to anything they do. And that just generally embeds aspects of quality assurance, right? So how they do code reviews, what kind of code reviews they do, and things like that. And then there's of course the more proactive way that is project specific. So instead of just looking at the software company as a whole, for this project, we're going to use 1, 2, 3, 4, 5, those tools, right? Can still be long running projects, so needs to be watched out for. And then there's quality control, which is kind of, okay, if things go sideways and you realize we have quality issues, how can we first of all fix it, but also feed it back, of course? So we either at least introduce it at project level, that we say, well, we haven't thought about coding convention for this particular submodule. Now let's introduce something about, the structures or the coding preferences for this one in the quality planning aspect to this project. Or more general, if you think, oh, that's actually disruptive, we need to change the organizational culture with respect to quality assurance, then of course needs to be fed into the top level process. And in all cases, you need to measure it, right? So it's all about measurement, finding some ways of measuring somehow. The argument there is, of course, a very orthodox one here. It's like measure everything and you know everything. In reality, that's not going to happen, right? You need to figure out your priorities. I think there's also the risk of doing a bit of a, but it's a good basis for doing optimization in your company with respect to your project development. But the risk is there that you expend a lot of time just developing metrics that may not actually help you really, right? So it's the question is how far you want to push those things. It's pretty much born out of a very classical focus on software development there. All right, yes, okay. So quality assurance is the idea of reviewing management processes, particularly with respect to project development, to ensure that any product that's coming out of this company is somewhat consistent with respect to those metrics. And of course, on a project level, that's much more fine-scaled and narrow, that a project meets requirements. It involves the development of project plans, of course, which are very explicit. So it's nearly like a document structure where we have a introduction, the plans, descriptions, quality goals, and the risk aspect. They're always too long. No one reads them anyway. So, but the point is, it needs to be sensible, right? Anytime you write something down, it needs to be within scope and also sensible. But again, documentation highly depends on what kind of project or customer you build for. And then, of course, the quality control needs to be done using some level of automation, right? So testing is quite important for this purpose, especially if you want to modify the project over time, but also allowing for inspections or reviews. And this may be a formal or informal review. That means, for example, if you develop a system that manages imports of goods for which you need to pay customs, for example, that means you need to be underlying a much harsher compliance requirements than just being able to review your code or your process. But you actually need to be able to transparently monitor or describe how a product is actually handled in your system, right? And that needs to be understood by auditors and not necessarily by coders, right? So the objectives here really depend on what kind of product you're dealing with, right? Otherwise you may just end up in jail, which is not optimal. Yes. Okay, I think I'll skip on this. I think you guys are fairly acquainted with the idea of doing code reviews and things like this. Right. So another differentiation that exists for development of software in terms of quality is one of them that focuses on the product itself, the outcome of what we're doing. Sounds good. Certain standards, needs to be reusable by someone else, but also the process. And that's something what this course is a bit about here, that you get a more strong grounding in terms of the processes that you need to undertake when you develop a product. So in practice, it means it's easier for people to leave and enter a project, and you can rely on the process more than on the people. So if you follow a particular step algorithmically for assessing the outcomes that of an individual commit or whatever else, then it's much easier to not to be concerned who's actually doing the review, especially in larger organizations. So the process becomes more central as opposed to the pure focus on the product. And that's the cycle as it's laid out for process-based quality. The idea: define initial process, develop the product, assess it, of course, the quality okay, well done. If it's not, then you need to improve your process. So that's the kind of idea. What you do. For example, if you realize you don't have an accurate metric for usability, well, guess what? You need to improve your process on developing this metric and then feed the project to it. Relatively straightforward, clear, classical iterative approach. Does it remind you of something? Sorry?
Prototype? Yeah,
prototyping, that's right. Prototyping goes, that's right. Prototyping has this thing of discarding product, right? And then start over. There's also that notion there as well.
Spiral.
Sorry?
Spiral? Because you're it's learning and then you keep on testing. You have
a continuous iteration exactly. It has this notion of spiral development, incremental improvement of the product. So relatively, I think it's fairly intuitive, the whole idea, right? So nothing of this is really magic, but rather straightforward. But sometimes you don't have the flexibility of just devising your own process structure, and the decision as to whether you do it or not. Sometimes you're coming into a company that works because it's big enough by certain process standards. And that's, I mean, you earn good money, but point is you need to buy into their standards. You don't have any choice. So in this case, all the processes are laid out. They may even be internationally standardized, or at least nationally standardized, or sometimes even by the domain you're working in, right? So certain medical standards you need to comply with, building standards you need to comply with, of course, but also other important standards that you need to be aware of. What do standards do? Well, of course, it's easy to lay out how you are supposed to perform a certain task. It includes best practices. You don't want to repeat past mistakes. It includes generally metrics that allow you to assess compliance, to find out actually or does my product meet the requirements that it's set out to meet potentially. And it supports the continuity. So the idea is that even if you have large companies with frequent turnover, you wouldn't need to bother because the standards will regulate, as I mentioned before, the quality of the product, right? So kind of, alienating from the people. No, not good. But anyway, that's how it works, right? So you delegate the responsibility to the process standard itself. You guys have certainly heard about ISO 9000, precisely such a standard, which defines all kind of different metrics and processes, how to ensure certain quality and how to basically arrive from setting out quality requirements towards specifying the factors, criteria, and then arriving at certain metrics that allow you to do so, and with respect to the actual process. Earlier versions of standards were the total quality management. The idea basically there was, well, we need to look at quality. If we deliver something to a customer product, we need to look at it holistically. That means pretty much all the partners that are involved should be consulted and considered. So it's along those lines. Hang on, I have a bit of a fun if you do diagrams that probably help there a bit. The idea is that it's super vaguely specified in principle, but fundamentally involves the idea that all employees should be involved, it should be centered around the process, it should be integrated, it should have a strategic perspective, fact-based decision making, and has a continuity component as well, so the idea is ticking all those boxes for your process internally would allow you to commit to this total quality management. So the idea is really to cover all your bases. That's the rough idea. But it's less structured as compared to ISO standards, for example, as well. Another one is the capability maturity model, where you assume that over time you start with relatively simple processes that are, unpredictable, go sideways, have a lot of overhead and so on. You identify processes that are regular and recurrent, that you do for every project. I don't know. For example, processes related to auditing or to accounting or something, things like that. And then you not only start to manage those processes, but actually pre-specify and define them, so it can be followed easily by newcomers, for example. And then you start actually to quantitatively manage them, right? How do you know that process is well managed or not well managed, right? Not just descriptive, but actually also having a feedback component. And then in the last stage, you use those metrics to refine a particular process, right? How to make the payroll easier and faster or whatever else, right? It really doesn't matter what process, it applies to all kind of processes you're dealing with, that they follow this maturation process or this scheme here. And if there's processes that only occur once a year, there may be a reason, it's a bad example, but for example, stock counting, right, is a relatively rare process, which is tough to optimize because you take a long time to actually reach there before you have actually repetitiveness in the process. But it's very important that it's reasonably well defined in order to meet compliance requirements. So you need to get quickly to that range there. So frequency of processes define how far you actually get in that ladder of different standards. What are possible process problems with those standards? Any ideas? You as a software developer, come in a company, they tell you, here, this is our 1000-page ISO 9000 document. Please read this and you'll be ready on Monday. We'll start with the onboarding at 9 o'clock. So, what's your impression there?
Difficult to absorb.
Huh?
Maybe difficult to absorb.
Yeah, not only that, yeah. Good weekend, right? Ahead of you there.
Quick.
Sorry?
Quick.
Quick, yeah. And what do you think about there? I mean, if you hear that kind of stuff, quality management for everything.
They are not flexible.
There you go. Not flexible, right? So you have to.
So it's the larger the sort of standard is, the more difficult it's going to be to remember everything.
Yeah. Luckily, though, good, bad, ugly, don't know. So. Yes, there's this thing just about the standards thing. You're absolutely right. Remember, it's very hard. One of the upside is, of course, there's a reference document at all times. You just need to figure out the right page. But the other thing is also, if you're working for a company that is certified by ISO 9000, you move to another company that uses the same standard. That is actually quite easy then, right? Because it defines also an intercompany interface in the widest sense, right? So depending on what you buy into as a developer and so on, then it can make things to some extent easier. But I fundamentally echo your intuitions there. Yeah, it smells like that, right? Bureaucracy from top to bottom. right? So it's really about forms, rules, and so on. And yeah, and how far this whole process is generally supported by software is also tedious. It may just mean you fall back to forms sometimes. So those seemingly structured processes can make things even harder if they're not properly supported, for example, by software, right? Well, so that's the overview there. Some points on quality management in Agile, perhaps quite in contrast here, of course. We give up on this rigidness, right? So who has seen Agile process being standardized by ISO 9000? I haven't, we hopefully never will. But the idea is really that you have this flexibility, right? So communication as much as possible, which DIPT pushes you to do, is quite centered. We have informal peer reviews, small releases, and frequent releases. However, what is measured and automated is really testing, right? You don't want to deal with that stuff anymore because this is one of the few things you can still quantify even if you do Agile easily, right? By writing tests and assess whether it's easy. Test-driven development, how does that work? Who did test-driven development? Who heard about it in lectures? Good. Forcefully, right? So what is it about?
You write a test bug before you develop the feature.
Yeah. So you write a test case?
Yes.
Before
So for example, like I want this feature to
Yeah.
I can like when I access this page, I will see this field.
Yeah.
And then when I submit, I put some those
Yeah.
points that you declare in the test, and then you run the test.
Yeah.
If it works, then your feature is okay. If
Yeah.
it's not, then you just
Yeah.
keep looking at the
Yes,
feature.
fundamentally it's this.
Yeah.
So what's one important criterion in test-driven development? One additional criterion that you generally... So you write the test first, what do you do then?
Don't know. Because
You did the right... I'm just pointing to one specific that is very particular about test-driven development.
Because I don't do it. I just hear about it
Yeah.
in lectures.
So, yeah, but you're right. So fundamentally, you have a feature, right? You write You have a feature that you want. Okay, cool. You write a test to test against this feature. You run the test and show that it fails, and then you develop the feature, and then ensure that it works or fails and refine. But the failing initially is important, right? So because this is also a test validation that the test doesn't just spit out true every time, right? That's the best test ever. Return true, and I'm good. So please.
But you need the requirements before you start development.
That's correct. That's right. The requirements. That's right. That's a bit annoying, right? So we need requirements.
There's not much test-driven development in the game industry.
In practice, it's very low. I mean, you notice in our bachelor degree, there's very limited use cases because you don't know the case enough, right? So it's too much prototyping going on. That's very true. That's true. But you still need to know what it is. So
Yeah, it's really good for APIs and web.
Yeah. REST, for example, is very testable. Perfect for test-driven development. I agree with you. And of course, it has a certain overhead, right? It's tedious. You write the test first, and you do the thing, and then you say, the feature's not what I want, so I need to rewrite the test, and then write the feature again. So iterative refinement becomes a bit tedious, while quality control is generally high. It's something to aspire to. How realistic it is really depends on your project, the time, the budget you have, and so on. Right? So, extreme programming. Did you guys need to do that somewhere before? You guys needed to, for sure. They already switched off. Yeah, come on, guys, old stuff. That's right. So basically, pair programming. The idea is to do extensive code review. One types, the other one reviews, right? At all times. You want to do extensive unit testing of everything you have, small releases, continuous integration, involve the customer as much as possible, and share ownership. And it's really about the code being at the center of your interaction. You communicate around the code, basically, right? By doing code reviews with the customer, but also yourself. Code reviews with customer is definitely one of the aspects that are there. Often requires a bit more people that are more involved on the development side. So having a big player, external customer, is a bit challenging to involve them in XP activities. But if you have a smaller startup kind of activity going, that's much more likely to deal with this. Scrum, you guys know. Flash structure, unit testing, review meetings, frequent integration, things like that, right? So small iterations is one of the key points that you want to bear in mind. Cool. Right. So the thing about Agile, what you can still do, and that will help some of you started this already, to develop a pool of test data that you keep using all the time. So you don't have to worry about the tests so much, as long as the data is kind of consistent over time, if it makes sense, of course, and then develop the test against it. Because Agile is a bit annoying in that things change quickly. So what's the most stable thing you have? Well, it's your data, usually. Right? So it's slightly different there. So yeah. So being proactive there. Metrics for your quality is the burnout chart and the running tested features. Those are good metrics in the context of agile development that you want to be aware of. Defect cycle time if necessary. So it's really about the errors that you have over time. Defect spillover. Yeah. Okay. So that's basically the idea is. The number of defects that actually don't get fixed in the planned sprint, but rather are being fed over to the next sprint. So basically, everything that comes to your backlog, and there's a kind of a defect, is also quality metric. Meaning you're probably not developing too well, but rather you're having most of the things you have in the backlog are not features, but actually defects. So if you have a relative metric between those two ones, it's also an indicator of your quality of your work to some extent. Okay, and then of course Simon mentioned velocity. So velocity is basically indicates the unit of work completed in a given sprint. If you measure it over time, you would want to see an increase in velocity, since it represents both your increasing skill set, but also your team cohesion, your ability of a team to work together. Basically, that's the idea. In order to measure how well your team really works. Okay, you nearly survived, or me? I don't know. One of us, anyway. For your project, see it as a reference slide set, okay? Don't learn it by heart. I don't think so. Need to ask Dipti. No, don't learn it by heart. But what you want to do, perhaps look for some quality attributes that you want to talk about or be aware of, right? Especially for your project. What's important for your client, especially for the guys that actually have a external client, right? So because they will be more or less explicit of what they want or not. But you can also go in your meeting, go to a client and say, hey, what about those quality attributes? Are they relevant for you or not? Because it's all about assessing, hopefully that you capture all the requirements from the get-go as early as possible, right? So use that, find out some measurable criteria and try to use them. I don't know. So perhaps you can actually employ them in your actual practice, even though you're small teams. But it may be a good exercise to just see how much you can quantify in terms of your performance metrics. Of course, you guys are a bit more on the agile side of things, so it's a bit harder there. But I think you should still think about it. Because again, Dipti will ask you again, how do you estimate this? On which basis did you make this guess? What's the systematic behind it, right? Why do you deviate from the orthodox Scrum process and so on? If you can justify it ideally based on some metrics, you're off the hook, right? So it's a very, very easy one to deal with this. Cool. Questions? That's just citation stuff. Questions? Who remembers anything of what I said? Hard to say, huh? Watch the stream, I guess. Yeah.
Regarding test-driven development, what frameworks have people been exposed to or tools?
Yeah. Did anyone test-driven development?
Using Unity tests.
Unity tests, yeah, cool. What else?
We did a lot of testing in application development in Java and JUnit.
The obvious choice.
All that stuff.
I mean, JUnit is the standard.
I've also worked with testing Golang.
Cool. I mean, yeah. I mean, when it comes to development, I think you as a representative of the game industry, as far as I know, there's no testing in that industry, right?
I don't know. I mean, the first company I worked for was Jagex, so they made RuneScape, which is the first multiplayer user dungeon, and they insisted in making everything themselves and not buying anything, not even Microsoft Office. So
right,
they made everything. So I think we actually use JMeter which is an external tool for pinging the server. That was pretty cool. I used that to migrate all the documentation to Confluence, which was handmade in HTML documents at the time.
So help me, JMeter, but JMeter is What do you do with this in your practice then?
You basically have like an interface where you can stack a bunch of tasks to remotely like ping an API and you get back a response. So you could chain a bunch of actions together. So for instance, I would download and pass the files from our file server, and then I would sign on to our Confluence, and then I would add pages in.
Yeah, I see. Oh, okay. So basically, API integration there.
Yeah. So, so you could use it for test-driven development, like
yes.
node testing, for instance. But you could also just use it if you wanted to automate a very long process.
Yeah. That's a good point. So if you so party testing is quite easy. In fact, it reminds me. Yes, of course, Go. Right. It also has rich. Who's doing Go again? Who are the guys? Yeah, the victims doing Go. That's cool. Check Go because it has a very solid, very powerful testing environment built into the language. Right. If you want to use that, and you can use or use it in a very similar way as Richard just describes, because you can of course use that as well to interrogate REST services in particular, which Go is really strong in. So that's something you wanna try and actually use from a quality point of view. Yes, that's right. What are other website testing? What kind of tools do you use for that? It's not so much TDD, but more testing tools.
I think for like front-end development, they have like tools like Jester for like React Native or React development.
Right.
The JavaScript libraries for backend, like Node.js, you can use Java, I think.
Okay.
So there's a lot of JavaScript.
Yeah.
Testing tools.
Selenium, does that make sense? Anyone hear about this?
I think I forgot the name of it, but for progressive web apps, there's a test suite for verifying functionality.
Yeah.
I just can't remember what it's called. But yeah, you can just.
Yeah.
I think Selenium is like for automatization of the testing process.
Yeah.
I have seen some application which written in Selenium, which like automatically checks the every like text editor or button.
That's right.
It works.
Yeah. So that's the user side of testing, right? So I mean, it's on one is UI testing. On the other hand, you can also see it as some form of integration testing, right? Because often applications are integrated via the UI, especially in the web space, right, where they actually integrate different web services. Exactly. Yeah. Very nice. Yeah. It's a completely scripted with testing environment. All right. Anyone else? More suffering? So what do we do in the next 1.5 hours? No? Okay. Lucky you. So I was tasked to talk about documentation, but that's not going to happen because I think else we all suffer. So we need to delay it to some extent. Okay, as far as your project goes, well, I think it's sensible to see in how far you can you use some of those techniques